40 Most Amazing Things Seen by New Horizons Spacecraft. Hello everyone, welcome to Space Explorer channel. The New Horizons spacecraft, launched by NASA on January 19, 2006, has been a source of wonder and discovery in the outer reaches of our solar system. Its primary mission was to perform a flyby study of the Pluto system, which it accomplished spectacularly in July 2015, and then continue on to explore additional Kuiper Belt objects. As New Horizons journeyed through the darkness, it sent back to Earth a treasure trove of information, unveiling the mysteries of distant worlds. Here, we delve into 40 of the most amazing things seen by New Horizons, focusing on its time exploring Pluto and its moons. Before moving forward, if you are new to our channel, please don't forget to like and subscribe our channel for future interesting videos. 1. Pluto's heart, Tombaugh Regio. One of the most striking features captured by New Horizons is the vast, heart-shaped region on Pluto named Tombaugh Regio, after Clyde Tombaugh, the astronomer who discovered Pluto. This iconic area, stretching over 1,000 miles across, is not only visually stunning but also offers deep insights into Pluto's geology and atmospheric processes. The discovery of this feature has transformed our understanding of Pluto, showcasing it as a world of unexpected beauty and complexity. 2. Charon's Chasms. Charon, Pluto's largest moon, surprised scientists with its dramatic landscape, notably its vast system of canyons, collectively referred to as Charon's Chasms. These observations challenge previous notions of the outer solar system's icy moons as geologically dead, instead presenting Charon as an object with a complex and active geological history. The discovery of Charon's Chasms by New Horizons has thus played a crucial role in reshaping our understanding of the dynamic processes shaping the surfaces of icy bodies in the Kuiper Belt. 3. Nitrogen ice flows on Pluto. The revelation of nitrogen ice flows on Pluto by New Horizons marked another intriguing discovery, illustrating the planet's active geological nature. These flows, found within the expansive plains of Sputnik Planitia, mimic the glaciers on Earth, albeit with a composition primarily of nitrogen ice, accompanied by traces of methane and carbon monoxide. The visuals captured by New Horizons display a dynamic environment where these icy flows creep across the surface, carving into the landscape and transporting materials over vast distances. The identification of these ice flows challenges our understanding of cryogenic processes in the outer solar system, providing compelling evidence of Pluto's surprisingly youthful and active surface. 4. Methane snow on Pluto's peaks. In a revelation that broadens our perception of Pluto's diversity, New Horizons discovered the existence of methane snow capped atop its mountain peaks. This discovery underscores the intricate interplay between Pluto's surface and its atmosphere, highlighting a cycle of condensation and sublimation that shapes the planet's icy exterior. This process, akin to the water cycle on Earth, but with methane taking the central role, adds a new layer to our understanding of planetary geology and atmospheric science in the outer solar system. 5. Vast icy plains on Pluto. The exploration of Pluto by New Horizons revealed the existence of expansive icy plains, a feature that significantly contributes to our understanding of the dwarf planet's geology. The plains also host a variety of other features, including dark streaks believed to be caused by wind-driven particles and possible ice volcanoes, hinting at a dynamic inner life. This landscape, eerily alien yet strikingly familiar, underscores the dynamic nature of Pluto and challenges our perceptions of the icy bodies in the outer reaches of our solar system. 6. Pluto's atmosphere haze layers. This discovery was pivotal in understanding the dynamics of Pluto's thin atmosphere, revealing that it is much more complex and stratified than previously thought. The presence of these haze layers suggests ongoing atmospheric processes, where ultraviolet radiation from the sun interacts with methane, leading to the creation of complex hydrocarbons and ultimately giving rise to this multi-layered haze. This phenomenon sheds light on the chemical reactions occurring in Pluto's atmosphere and has significant implications for our understanding of atmospheric evolution on other celestial bodies in the outer solar system. 7. Kerberos, Pluto's moon. This small moon, measuring approximately 7.4 miles in its longest dimension, appears to be composed of two larger lobes joined by a brighter, narrower neck, hinting at a possible violent past of cosmic collisions and agglomerations. The disparities in surface brightness and composition have led scientists to speculate about Kerberos' formation and evolution, suggesting it might have accreted from the debris of a collision between Pluto's other moons or a captured Kuiper belt object. New Horizons' flyby of Kerberos has provided invaluable data, contributing to our growing understanding of the intricate dynamics and history of Pluto's satellite system. 8. Styx, Pluto's moon. This small moon, named after the mythological river that separates the world of the living from the dead, presents a low reflectivity surface, indicating it is covered by water ice and possibly other ices, similar to its neighboring moons but distinct in its specifics. Its irregular shape and orbit suggest a turbulent past, possibly involving gravitational interactions with Pluto's other moons or the capture of a Kuiper belt object. The data on Styx has expanded our knowledge of the complex celestial dynamics at play within the Pluto system and highlighted the diversity of natural satellites in our solar system. 9. Nix, Pluto's moon. Intriguingly, high-resolution imagery uncovered a region with a distinct red tint, suggesting the presence of organic molecules or tholins produced by the interaction of sunlight with methane ice. This feature indicates complex chemical processes at play, similar to those observed on Pluto's surface, but unique in its manifestation on Nix. Additionally, craters and varying terrain textures observed suggest a history of impacts and possibly internal processes that have reshaped Nix over time. Through these observations, New Horizons has significantly deepened our understanding of the myriad conditions and evolutionary paths of celestial bodies in the Kuiper belt. 10. Hydra, Pluto's moon. The imagery from New Horizons revealed an elongated shape and surprising brightness, suggesting a complex surface coated with reflective ice. Unique surface features, including craters and varied terrain, hint at Hydra's dynamic history, possibly marked by collisions and interactions within the Pluto system. These insights into Hydra's characteristics underscore the nuanced and varied nature of moons in the outer solar system, offering a glimpse into the processes that govern their formation and evolution. 11. Sputnik Planitia. Sputnik Planitia is a vast, heart-shaped basin filled with nitrogen ice, located in the western lobe of the iconic heart feature on Pluto. This expansive plain, one of the smoothest regions observed by New Horizons, showcases intriguing patterns of ridges and troughs, indicating a dynamic and possibly convective ice layer. The stark contrast of its bright surface against the darker terrains that surround it highlights the diversity in Pluto's geological landscape. Evidence of glacier flows and the interaction with Pluto's thin atmosphere further adds to the fascinating story of Sputnik Planitia's formation and evolution. 12. Pluto's mountains. Pluto's mountain ranges, reaching as high as 11,000 feet, defy expectations with their rugged terrain, towering above the surrounding plains. These icy peaks, primarily composed of water ice, starkly contrast against the nitrogen and methane ice that dominate the landscape. The presence of such mountains suggests geological activity in Pluto's past, challenging prior notions of the dwarf planet as a geologically dead world. Among these majestic formations, the Norgay Montes and Hillary Montes stand out, named in honor of the first climbers of Mount Everest, symbolizing the spirit of exploration that New Horizons embodies. 13. Pluto's valleys. Pluto's valleys present a captivating landscape, carved into the surface over eons. These vast depressions reveal the complex interplay between Pluto's geology and climate. The most prominent, Valles Marineris, showcases deep, intricate channels that may have been formed by ancient glacial movement or tectonic activity. The variation in depth and width across these valleys hints at a diverse geological history, offering insights into the processes that shaped Pluto's unique terrain. Their existence underscores the dynamic nature of the dwarf planet, further challenging our understanding of celestial bodies in the Kuiper Belt. 14. Pluto's craters. Pluto's surface is punctuated with craters, each telling a story of impacts that have shaped the dwarf planet over millions of years. These craters vary widely in size, depth, and composition, providing clues to the age and history of the surface. Some of the most notable craters exhibit bright rays and halos, suggesting relatively recent collisions. Others are softened by erosion, indicating their ancient origins. The distribution and characteristics of these craters offer invaluable insights into the cosmic events that have influenced Pluto and its moons, painting a picture of a dynamic and ever-evolving world. 15. Pluto's plains. The plains of Pluto, vast expanses of ice, reveal a landscape of unexpected complexity and variety. Notably, the Cthulhu Macula stands out as a dark, expansive area, contrasting sharply with the brighter ice surrounding it. These plains, marked by a patchwork of craters, hills, and smooth surfaces, tell tales of geological processes at work. Erosion, sublimation, and perhaps even cryovolcanic activities have played roles in sculpting these features, offering a glimpse into the dynamic nature of Pluto's surface. Their composition, primarily nitrogen ice mixed with carbon monoxide and methane, adds another layer to our understanding of the dwarf planet's diverse terrain. 16. Pluto's tectonic features. 17. Pluto's polar ice caps. The polar ice caps on Pluto are a striking feature, comprised mainly of methane and nitrogen ice. These caps, residing at both the North and South Poles, exhibit a bright, reflective surface, contrasting with the darker regions of the planet. The seasonal variation leads to fascinating changes in their size and shape, as sunlight sublimates the ice, causing it to redeposit in different areas. This process, alongside the unique atmospheric conditions of Pluto, plays a crucial role in the ongoing cycle of ice accumulation and erosion on the dwarf planet's poles. 18. Charon's Dark Pole. The North Pole of Pluto's moon, Charon, presents a mysterious dark region, often referred to as Mortar Macula. This unusual feature stands in stark contrast to the rest of Charon's largely icy surface, covered in a thin layer of dark material. Scientists hypothesize that this darkening is due to the accumulation of tholins, complex organic molecules formed when cosmic rays and ultraviolet light interact with methane gas escaping from Pluto's atmosphere. This interaction, and the subsequent deposition on Charon, suggest a fascinating chemical and physical connection between the two celestial bodies. 19. Charon's impact craters. Charon's surface is marked by numerous impact craters, providing a stark record of collisions over time. These features range from small, sharp-edged pits to large basins, illustrating the moon's tumultuous history with space debris. The variation in crater size and depth offers insights into the moon's crustal composition and the dynamism of its geological past. Some craters show signs of partial infilling or erosion, hinting at possible past internal activity or interactions with Pluto's escaping atmosphere. These craters serve as windows into Charon's evolution, highlighting its role in the complex gravitational dance with Pluto. 20. Charon's Plains. Charon's Plains, vast stretches of relatively smooth terrain, reveal a fascinating aspect of this moon's geology. Unlike the rugged, cratered areas, these plains suggest a history of resurfacing, possibly through cryovolcanic flows or the settling of materials from above. The uniformity and composition of these areas indicate a quieter, yet equally intriguing, period in Charon's geological history. Observations of these plains help scientists piece together the Moon's past, uncovering the forces that have shaped its surface over eons. 21. Charon's Canyons. Among the most striking features revealed by the New Horizons spacecraft are the vast canyons etched into Charon's surface. These enormous geological formations are some of the largest in the solar system, with depths reaching up to 7 miles and widths spanning several miles across. The discovery of these canyons provides compelling evidence of Charon's dynamic past, suggesting that internal geological processes once shaped this frigid moon surface. The existence of these canyons challenges our understanding of planetary geology and hints at the complex histories of celestial bodies far beyond the gas giants. 22. Pluto's retrograde rotation. Pluto stands out in the solar system not only for its striking landscapes, but also for its unusual rotational direction, known as retrograde rotation. This means that Pluto rotates on its axis in the opposite direction to most planets in the solar system, including Earth. This unique characteristic causes the Sun to rise in the west and set in the east on Pluto, contrary to what we experience on our home planet. The discovery of Pluto's retrograde rotation by the New Horizons mission adds another layer of mystery to this distant world, further intriguing scientists and space enthusiasts alike. 23. Charon's synchronous rotation. Charon exhibits a fascinating orbital dance with Pluto, characterized by synchronous rotation. This means that Charon always presents the same face towards Pluto, a trait that is a direct consequence of the gravitational interactions between the two celestial bodies. Such synchronous orbits are common among planetary satellites, but witnessing this phenomenon between Pluto and Charon offers a unique glimpse into the complexities of gravitational forces at play in the outer solar system. This celestial ballet underscores the intricate relationships and dynamics that govern the motions of distant worlds. 24. Pluto's dynamic atmosphere. Pluto's atmosphere is far more dynamic than anyone anticipated, with layers of blue haze that stretch over 100 miles above the surface, creating a stunning visual effect. New Horizons revealed this atmosphere to be composed of a complex mix of gases, including nitrogen, methane, and carbon monoxide, which undergoes dramatic seasonal changes. These findings are pivotal, suggesting that despite its distance from the Sun, Pluto experiences atmospheric processes similar to those on Earth, yet under far colder conditions. This discovery highlights the unexpected nature of Pluto's environment and its ability to surprise and intrigue scientists. 25. Pluto's ionosphere. The exploration by New Horizons unveiled a remarkable discovery. Pluto possesses an ionosphere, an atmospheric layer filled with charged particles. This ionosphere is formed when the Sun's ultraviolet light ionizes its thin atmosphere, a surprising feature for a body so distant from the Sun. The existence of an ionosphere around Pluto provides valuable insights into its atmospheric composition and the interactions between the solar wind and Pluto's magnetic field, showcasing the complex and active nature of this dwarf planet's environment. 26. Pluto's solar wind interaction. The New Horizons mission has also shed light on Pluto's interaction with the solar wind, a stream of charged particles emanating from the Sun. Surprisingly, despite its distance, Pluto's atmosphere and its ionosphere interact with this solar wind, creating a tail-like structure of ionized particles. This interaction, similar to a comet's but on a planetary scale, provides invaluable data on how the solar wind influences the atmospheres of distant celestial bodies, contributing to our understanding of space weather dynamics across the solar system. 27. Kuiper Belt objects. The Kuiper Belt is a vast, unexplored region of space beyond Neptune, filled with ancient remnants from the solar system's formation. New Horizons' journey through this icy frontier has offered us a glimpse into a world of diverse objects, ranging from small ice bodies to dwarf planets like Pluto. These objects, often called KVOs, vary in size, shape, and composition, revealing a complex history of collisions, accretion, and gravitational interactions. The spacecraft's encounters with KBOs have illuminated the processes that shaped our solar system's outer reaches, offering clues to its early architecture and evolution. 28. Arrokoth, 486,958. 2014 EMU 69. Arrokoth, designated 486,958 2014 EMU 69, unveiled as a significant milestone for New Horizons, stands as a testament to the spacecraft's exploratory prowess. This ancient Kuiper Belt object, shaped like a flattened snowman, consists of two lobes that gently merged in a slow-motion collision billions of years ago. The exploration of Arrokoth provided crucial insights into the building blocks of planet formation, offering a pristine window into the early solar system's dynamics. Its smooth, light-colored surface, marked by few craters, suggests a relatively unblemished object, preserving the secrets of the primordial past. 29. Kuiper Belt debris. Navigating through the Kuiper Belt, New Horizons has encountered not just large objects like Arrokoth, but also a myriad of smaller debris. This debris, consisting of ice, rock, and dust, offers critical clues to the formation and evolution of the solar system. These fragments are remnants of collisions and interactions that have occurred over billions of years, painting a picture of a dynamic and ever-changing region. The study of this debris aids scientists in understanding the processes that govern the Kuiper Belt's complex ecosystem, shedding light on the mechanisms of planetary accretion and the origins of the solar system's outermost regions. 30. Distant comets. As New Horizons ventured deeper into the Kuiper Belt, it captured intriguing views of distant comets, celestial wanderers composed of ice and dust. These observations have enriched our understanding of comet trajectories, composition, and interaction with the solar system's environment. By studying these distant comets, New Horizons has provided invaluable data on their life cycles and origins, offering glimpses into the processes that may have delivered water and organic compounds to the early Earth, thereby contributing to the emergence of life. 31. Interstellar dust. As New Horizons journeyed through the cosmos, it encountered the delicate yet profound world of interstellar dust. These tiny particles, remnants from the formation of stars and planets, paint a complex picture of the galaxy's life cycle. New Horizons, equipped with its sophisticated instruments, was able to analyze the size, composition, and distribution of these dust particles, offering insights into the building blocks of the solar system. The spacecraft's observations have significantly contributed to our understanding of how these particles interact with solar wind and radiation, influencing the structure and dynamics of the heliosphere. By studying the interstellar dust, New Horizons has provided a clearer image of the cosmic environment through which our solar system moves, unveiling the intricate balance between the forces shaping our galactic neighborhood. 32. Interstellar medium. The interstellar medium, a vast expanse filling the spaces between the stars, was another realm explored by the New Horizons spacecraft. This complex mixture of gas, dust, and cosmic rays plays a critical role in the life cycle of stars and the formation of celestial bodies. New Horizons instruments, peering into this barely visible domain, help to map the distribution and density of these materials, revealing the hidden forces and processes at work in the galaxy. This exploration not only added depth to our knowledge of the cosmos, but also highlighted the interconnectedness of the universe's various components, showcasing the intricate tapestry of matter and energy that exists beyond our solar neighborhood. 33. Magnetospheric boundaries. These invisible barriers are formed by the solar wind's interaction with planetary magnetic fields, creating a protective shield against cosmic radiation and interstellar particles. The spacecraft's journey provided rare insights into these dynamic regions, especially around Pluto, revealing how the solar wind is deflected and shaped by these magnetic fields. By studying the variations in magnetic field strength and particle fluxes, New Horizons has helped to decode the complex processes that govern the magnetospheres of celestial bodies. This exploration not only deepens our understanding of planetary protection mechanisms, but also unravels the fundamental aspects of space weather's influence on planetary environments. 34. Solar wind properties. In its extraordinary voyage, New Horizons has delved into the properties of the solar wind, a stream of charged particles released from the Sun's atmosphere. This relentless flow, consisting mainly of electrons, protons, and alpha particles, shapes the environment of our solar system. By measuring the speed, density, and temperature of the solar wind far beyond the orbit of Neptune, New Horizons has provided invaluable data on how these particles interact with the magnetic fields and atmospheres of distant celestial objects. 35. Heliospheric boundary. New Horizons, in its pioneering journey, has provided a rare glimpse into this remote region of space, where the solar wind slows down and changes direction due to its interaction with the gases and particles of the galaxy. This boundary, also known as the heliopause, is crucial for understanding the protective bubble that surrounds our solar system, shielding it from cosmic radiation. The data gathered by New Horizons about this boundary helps scientists to model and predict changes in our solar system's protective barrier, offering insights into how these external pressures impact the heliosphere's shape and size. Through the spacecraft's exploration, we gain a deeper appreciation for the dynamic nature of space, where the Sun's domain meets the vastness of the galaxy. 36. Cosmic rays. Cosmic rays, the high-energy particles that travel through space at nearly the speed of light, present a fascinating area of study for the New Horizons spacecraft. Originating from the Sun and distant cosmic events like supernova, these particles journey across the galaxy, carrying with them the secrets of the universe's most energetic phenomena. By detecting and analyzing cosmic rays, this research sheds light on the processes that accelerate these particles to their incredible speeds and how they may affect space weather and the environments of planetary systems. Through its observations, New Horizons helps to unravel the mysteries of these elusive particles, adding a crucial piece to the puzzle of cosmic dynamics and energetics. 37. Heliosphere structure. The heliosphere's structure is a complex, vast bubble formed by the solar wind as it collides and interacts with the interstellar medium. This shield-like boundary encases our solar system, extending well beyond the orbit of Pluto, and acts as a protective layer against external cosmic radiation. These insights have come from the spacecraft's detection of charged particles and magnetic fields, illustrating the heliosphere's dynamic nature. The observations suggest variations in thickness and density across different regions, indicating that the heliosphere is not a uniform bubble, but a fluctuating, responsive entity. 38. Ultraviolet imaging. Ultraviolet, UV, imaging by New Horizons has unlocked a new window into the understanding of celestial bodies and their atmospheres. This method, leveraging the unique capabilities of the spacecraft, has allowed for the examination of stars, planets, and comets in the ultraviolet light range, revealing features invisible to the naked eye or through conventional optical telescopes. This technique has also enabled the observation of auroras and other atmospheric phenomena on distant worlds, offering a deeper insight into the electromagnetic processes occurring in their environments. Through ultraviolet imaging, New Horizons continues to broaden our cosmic perspective, peeling back layers of the unknown in our quest to understand the universe. 39. Infrared spectroscopy. Infrared spectroscopy aboard New Horizons has been a key tool in deciphering the chemical compositions and temperatures of celestial bodies encountered during its voyage. For Pluto and its moons, these observations offered unprecedented insights into their surface geology and thermal characteristics, highlighting variations in terrain, such as ice flows and mountain ranges, and even suggesting subsurface oceans. This method has been instrumental in expanding our understanding of the outer solar system's composition and the processes shaping these remote worlds. Through its infrared spectroscopy capabilities, New Horizons has significantly enhanced our knowledge of the molecular makeup and thermal dynamics of the solar system's frontier. 40. Solar wind observations. Delving into the solar wind's mysteries, New Horizons has offered an unprecedented look at this critical component of space weather far beyond the usual bounds of study near Earth. By meticulously observing the speed, density, and temperature of solar wind particles in the uncharted territories of the outer solar system, the spacecraft has enriched our understanding of how these charged particles traverse the vast expanse of space. These observations are crucial for comprehending the interactions between the solar wind and the magnetic fields of distant celestial bodies. If you enjoyed from this video, please don't forget to like and subscribe our channel for future interesting videos. Thanks for watching.